All right. Starting that timer. All right. Here we go. Solubility rules with Miss Stanley. Solubility is essentially the ability for something to solute. Okay, so basically it's the ability to dissolve, right? Think about how Kool-Aid your Kool-Aid is. That's what I always say. But the important part is knowing what's going to dissolve and what isn't going to break up. And if something doesn't break up, then it forms a solid. And if something doesn't break up, it's called a precipitate or a precipitate or precipitate, whatever you want to call it. Okay. But as long as you recognize that it is in fact a solid. Okay. That is the goal. Now today we're going to use our solubility table, periodic table, and this cool activity to determine what exactly is soluble and what's not soluble in water. So let's look at this first one, KBr. In this compound, we have two different things. We have potassium, and we also have bromine, okay? Potassium, looking at your periodic table over here, potassium is in group 1. We also have fancier names for group 1 now. It's called group 1A. Does it mean anything different? No, it's just another name for group 1. We have potassium in group 1, and then over here we have bromine in group 17. And bromine has a charge of -1. So when you're doing this, let's go ahead and assign our charges. So potassium is going to get a +1, and bromine is going to get a -1 charge. Now, our goal is to figure out, is this going to be a solid when mixed or combined with something, or is it going to be soluble or aqueous? All right. Now, looking at our solubility table, we have potassium down here at the bottom, and it tells us that it is soluble and there are no exceptions. That means that it's on the back. Sorry, I didn't say that part. My bad. It's on the back of your periodic table. My bad. Yes, so if I'm looking at this table, top left, we can see that potassium, K+, is soluble and there are no exceptions to it. That means that when combined with bromine, it is in fact soluble in water. So we can put an X in the column for soluble in water. Next, I have lead and CO3, which is carbonate. Let's see. I don't see lead on my ion list, but I do see CO3 2-. Do you guys see it in our solubility rules list? What does it say about CO3? CO3 2-. It's mostly going to be what? Insoluble, which means it's not going to break up. It's going to form a solid, except when it's combined with elements in group 1A and with NH4+. Now, lead going to be in our group 1A? Well, if I'm looking for lead on the periodic table, it is not in group 1A, meaning that this compound is going to be what? Not soluble in water. So we can put an X in that category. Good. Zinc hydroxide. All right. Hydroxide. You may not know what hydroxide is, but if you look in your handy dandy polyatomic ions chart on the bottom left-hand side of your periodic table, what is the compound hydroxide?
The -OH.
Good. -OH. So that means that we have zinc and -OH in this compound. What does it say about OH, -OH right here? It is mostly going to be what when combined with something? Good. Insoluble, except when we're with a group 1A ion, calcium, barium, or strontium, which we don't. We're with zinc. So it's going to be what? Good job. Not soluble in water. Everybody kind of get the gist of that? Now, like any good chemistry assignment, let's make it more difficult. So, scrolling on the back here, look on the back of that document. Essentially, what we're going to be doing is building reactions. You're going to take the element at the top and the element and the compound on the side and create a reaction. All right. Now, when we write this out, it matters what it looks like. So let's write it together. We're going to have, let me see if I can use this. Uh-oh. Go on with your bad self, Miss Stanley. Go on with your bad self. Look at you. Okay. So what we're going to have is KBr plus AgNO3. I'm about to move some stuff around. Pause. Oh, it's still going. Okay, perfect. So we're going to take potassium bromine plus AgNO3. Now we need to make some products. Essentially, we're going to have a double replacement reaction. You remember those from back in the day, the wife swap? Mm-hmm. So we have 4 pieces here. Our first piece is potassium. Wow. Second piece is bromine. Third piece is silver. Fourth piece is NO3. Okay. Now we're going to swap our bromine and our NO3. Now, before we get really excited about swapping stuff, we got to make sure we recognize our charges. What is our charge of potassium? Look on your periodic table. It is. Everybody see that up at the top? It's going to be a +1. Okay. Now, what's your charge of NO3? Plot twist, it's a polyatomic ion. So look on the bottom left-hand side of your periodic table, other side. Yep, bottom left-hand side, NO3. What's the charge of NO3?
Minus?
Yep, so it's going to be NO3 minus 1. Now, we need to cross-lock and drop our charges. This is the part where it gets a little funky. Now, if I'm crossing and dropping 1s, do I have to write those 1s in the final compound, or can I just leave them be? Like, do I have to write K1NO3 1, or can I just write KNO3?
You can just write it.
Correct. I can just write KNO3. Okay. Now, the next compound has silver, which is Ag. Okay, now we need the charge for silver. Silver is in the valley. So right now, go ahead and get your periodic table and add a +1 by silver on your periodic table, because you'll need that when you take your test. Silver is in the valley. It's right under copper, which is in group 11, element 47. You can add a +1 to your silver. And now, who can tell me my charge of bromine?
Bromine is negative or -1.
Good. And when I cross-lock and drop those +1s and -1s, what is the final compound going to be? What's your question?
I'm good. I'm just
Okay. I was about to say, because bromine is right here. That's why we know it's -1. And silver right here, put you a +1 right there. In the little box. There you go. There you go. Good. You're welcome. All right. So this is my final sentence, or my final equation. We have KBr plus AgNO3 yields KNO3 plus AgBr. Now we got bromine from the right side of the periodic table with a -1 charge. Any questions about what we just did right there? Good. Now we need to establish the states. So that's what we're going to write in parentheses by each of these compounds. On the left side, they told us that these are all aqueous. So we're going to put AQs next to each of these. Literally the letter A, literally the letter Q. So parentheses AQ, parentheses AQ, right next to it. On the left side, rewrite this compound right there. Now we need to figure out if KNO3 and AgBr are insoluble or soluble. What am I going to use to determine that? How am I going to find out if these two compounds are soluble or insoluble? What am I going to use?
The table?
Good job. The solubility table. Solubility table. What does it say about compounds that are with potassium? Using your solubility table on the back of your periodic table.
Soluble.
Correct. The majority are soluble. So with your potassium, the majority are soluble, which means your state symbol, or what we write in parentheses, is going to be AQ. AQ is just another way of saying soluble. Okay, now we have AGBR. So let's use our chart to see if we can find anything about AGBR. You see any rules about AGBR? No, that means that it's going to be insoluble. So it's going to form our solid. So in parentheses next to AGBR, we're going to put an S. An S, because it's going to form a solid or a precipitate. Now our directions tell us to circle. What does it say to do?
Circle the formulas.
For the precipitate. Okay, so we need to circle AGBR because that is our solid. Yeah, maybe so. All right, let's do another one.
So do we put that in this box?
Correct. Put the final formula and the state symbols in the box. Want to try the next one? Let's do, are we going to the right or down? Which one are we going to go? Which way do we want to go?
I'm going down.
Let's go down then. Because we're yelling timber. All right, here we go. So this one is going to be KBr plus BaCl2. Perfect. We'll work one more. KBr plus BaCl2. Now, when we do this, what are our products going to be? We're going to break them up and then put them back together. So we're going to have K, which has a +1 charge, and what? Potassium's new partner is going to be who? Say it again. Close. We're going down.
Oh.
It's okay. Who is potassium's new partner then? You're going to pick Cl because Ba is a metal. So we're going to pick the second one. Okay? So K, which has a +1 charge, and Cl, which has a what charge?
Minus.
Minus. Do y'all notice how we're writing these like twice almost? You know, it's like you write it, and then you write the final one, and then you have your state symbols. It's a lot of rewriting, but once you get the hang of it, you'll know how much space to use. All right. Once you cross-lock and drop those charges, what do you end up with as your final compound with potassium and chlorine? You have ones being crossed, so it's going to be K, then what?
KCO.
Good. KCO. All right, next, let's do the next pair. We have barium. Who is barium's new partner?
BR.
Good. What is the charge of barium? Ba. Look on your periodic table. One vote for +2. Does anybody else agree? +2. Good. And then what is the charge of bromine? One vote for -1.
Negative.
Good. All right. Now, cross, lock, and drop. This is when it actually applies. So you're going to have barium, which gets the 1, but bromine gets a what? A 2. So it's BaBr2. All right. Now, our final equation here is KBr plus BaCl2 yields KCl plus BaBr2. Now, throwing it back a little bit further, is this balanced? Do you have the same number of each compound on each side? No, you do not. So,
Where did this CO2 go?
say it again.
Where'd the CL2 go?
The Cl2? What do you mean the Cl2?
It was 2 here. Where?
Right. You don't carry the subscripts with you across the arrow.
Ah.
So it's just an independent compound moving left and right. So it's just chlorine. That's why we don't have a 2 on that side. Okay. So now to balance this, we need to put a 2 in front of our KCl and a 2 in front of our KBr. 2 in front of KBr and a 2 in front of KCl. That balances it because now we have the same on each side. All right, now looking at our states. On the left side, KBr is going to be aqueous and BaCl2 is aqueous. Now, who can tell me about KCl?
Aqueous.
Why do you vote aqueous?
Because Cl is soluble.
Correct, and so is potassium, so it's going to be aqueous. Now talk to me about BaBr.
Non-soluble.
And why do you think that?
Because it's not on the solubility table.
Correctamundo. It's going to be our solid, which means we circle it.